Houston, we have well, a whole bunch of space rocks actually. Welcome to the Macke Makerspace. Hi, I'm Brother Bob Macke. I'm the curator of meteorites at the Vatican Observatory, and I am really excited right now. So this video marks the culmination of a project that's been going on for several years. And in case you've missed the previous videos in this series, let me provide a little bit of background. So in 2020, the OSIRIS-REx spacecraft touched the asteroid Bennu and collected a bunch of pebbles and dust from the surface. And it then began its years-long journey back home. Meanwhile, back on Earth, preparations were underway for analysis of the specimens when they would finally arrive, and that's where I come in. The sample analysis team asked me to develop and build an ideal gas pycnometer to study the density and porosity of rocks from Bennu. And this is a device that uses pressurized gas in a container of expanding volume to measure the volume and density of a specimen that's placed inside it. But there was a catch. This could not contaminate the specimens in any way and would have to be installed inside a cleanroom glove box. And that meant that it could only be made out of a small list of approved materials like certain types of stainless steel and aluminum. And all the valves and electronics would have to sit outside the glove box, so this made the design even more complicated. Slowly, over the course of a couple of years, the design was developed and perfected with a prototype that you might have seen in a previous video. In the spring of 2023, we started work on the final instrument. Orders were sent out to specialty manufacturers for most of the components, and machine shops around Tucson were tasked with the milling of the many steel and aluminum pieces that would form the structure of the device. All the many parts were shipped to NASA's Johnson Space Center in Houston, Texas, where they had to be individually cleaned and sterilized. So here they are wrapped in Teflon bags to keep them clean. So then assembly took place in the clean room itself. But I was stuck in Italy over the summer, so my colleague Dr. Andy Ryan assembled the instrument in my stead. And when he worked on the parts that go inside the glove box, he had to don the full bunny suit. Here he is wrapping the threads of a fitting with Teflon tape so he can attach it to the mounting plate that separates the parts that are inside the glove box from the parts that are outside. And it's just one of hundreds of parts that had to fit perfectly together. And I was rather concerned because we didn't have a chance to test fit most of the pieces before this event, and Andy was following assembly instructions that I wrote in Italy based on my computer model of the pycnometer. Apparently, the instructions were good enough, because after assembly we tested it and it worked properly. We did have to tweak one of the power supplies that was providing a slightly lower voltage than it should have, but that wasn't a big deal and we resolved the issue pretty quickly. Now for the real test. Does it actually fit in the glove box porthole? This test in the fall was the first time the two objects ever saw each other, and the technicians had to carefully maneuver the sample chamber into the small hole, and then the rest of the pycnometer slid fairly easily into place. And I can't tell you how much of a relief it was to see those bolt holes line up. The curators at JSC also took the opportunity to test the ergonomics of working with the pycnometer and found that they could easily reach the necessary parts and manipulate them as appropriate. In this clip, they're sealing the sample chamber lid, which was brought into the glove box through the airlock, and it can easily be manipulated while wearing those thick gloves. They also tested the special tweezers that we modified as an extraction tool to remove samples from the pycnometer chamber. After these tests were all done, they removed the pycnometer and packed it up until it would be needed for realsies. This brings us to the big event. On September 24th, 2023, the long-awaited sample recovery capsule was scheduled to fall through the Earth's atmosphere until it slowed down enough for a parachute to deploy, followed by a gentle descent to the ground in the Utah Test and Training Range, to be recovered by a specially trained team of curators, scientists, and engineers. Now, I wasn't among them, though. Instead, I attended a watch party at the former OSIRIS-REx headquarters, the Drake Building at the University of Arizona. There, a bunch of OSIRIS-REx team members observed a live feed of the EDL procedure, short for entry, descent, and landing. And it was a big celebration for us all, especially for those who were involved in the project from the very beginning back in 2009.
That starts a very complex labyrinth network of piping and tubing leading into that sample capsule. But just a few years ago was on the other side of the solar system from us sampling an asteroid Bennu. The team has incredible precision on this mission as well. Just a few days ago, on the 17th of September, they did their final trajectory correction maneuver, TCM-12. This corrected our velocity by 3 millimeters per second. Just a sigh of relief from the team. I can hear some applause here. Here is that orange creamsicle color parachute.
The capsule recovery went by the numbers, and the sample canister containing the TAGSAM head was loaded on a cargo plane bound for Houston. And it was taken directly inside the Astromaterials curation facility and brought to the OSIRIS-REx clean room. They put it in a glove box, the same one in fact where the pycnometer would be installed, where they could carefully open it up to reveal the TAGSAM and some of the treasure hidden inside. And there were a few nice stones on top of the TAGSAM's mylar flap, but even more hidden in the container underneath. Perfect for pycnometry. Then the TAGSAM head got moved over to another glove box where they could work on it better, and it was finally time to install the pycnometer for realsies. And I think this process went much more smoothly than the test run. They clearly had more confidence in what they were doing. And they hooked it up to the same nitrogen gas feed that is used to purge the glove box. And after that, I plugged in the electronics box and the computer that runs the pycnometer software. Don't I look great in the bunny suit? The first order of business is some witness foil tests. I mentioned earlier that the device could not contaminate the specimens in any way. And to be sure of this, we had to test it on some clean aluminum foil strips. So here, the glove box operator is opening the lid of the chamber after one of those tests, so she can remove the witness foil. The test strip is the small rectangle that she's holding with the tweezers. The witness foils, along with the control strip, are then containerized, and yes, that's a technical term, and shipped to labs for analysis. And there, they will confirm that the pycnometer is clean so that we can start measurements of the space rocks from the asteroid Bennu. We're looking forward to a lot of great science coming out of this project. And this would not have been possible without the involvement of a whole host of other people beyond just myself. In fact, there are way too many people to try to name them right now, so I'm going to try to list them in a credit slide at the end of the video. The Pycnometer project was funded by the OSIRIS-REx mission at the University of Arizona. And while the Vatican Observatory did not sponsor this video or my channel, I do make use of their facilities and resources for video editing and such. The purpose of the Vatican Observatory is to be a sign to the world of the compatibility of faith and science and of the Church's support of science. And it could use your support. If you'd like to support the work of the Vatican Observatory, or even just to learn a little bit more about it, there is a link in the description. Please check it out. So this is the last video in this series, but don't worry, there are more videos on the way for other projects that I'm involved in. So please be patient though, as I will be kind of busy with this whole OSIRIS-REx thing for a couple of months, and it might be a few months between videos for a little while. So now it's time to get back to sciencing all the science we can science out of these space rocks. So until next time, peace.